Hi, my name is Daniel Santiago and I'm a software engineer at Google, and in this video I'll be talking about Hilt, an Android dependency injection library. I'll go a bit onto how to set it up, how does it work internally, and a quick recap on what is dependency injection. Because we can't have a video about dependency injection without first defining what it is. You might have heard of this already or already know it. It'll be a quick recap and it'll be good for some follow-up points I'll be making. In essence, dependency injection is a programming pattern. Here's a concrete example. If we have a music player, it's a class. It needs a database and some codecs to work. In a world with no dependency injection, these dependencies to make music player work are instantiated by that class itself, in this case the music player. To use a music player, it's pretty straightforward. You instantiate it and start using it. Now with dependency injection, these classes that the music player need are not built by the player himself. They come as constructor arguments. And when using the music player itself, we have to build those dependencies, then build the music player and start using it. So it kind of shifts a little bit the logic of where things get created. Now we actually had a dependency injection talk in the Android Dev Summit of 2019. Here's a link to that video, and it goes into more detail on the theory of dependency injection and the benefits of it. But to basically recap, we highly recommend that you use dependency injection in your code base. It does have quite a few benefits. Easier configuration changes. That music player had an SQLite database. Maybe I want a different type of database, or I want to add more codecs. It should be easier on testability. And things are loosely coupled and it's easier to reuse code and a few other things. We also mentioned on that talk that you should definitely use a dependency injection library, because doing manual injection can get pretty hairy. It could get a lot harder, because if you have a bunch of dependencies, then you have to create all of those in the right order and so forth. The thing about dependency injection, or specifically, it's that it's hard in Android because you don't own the framework classes. Classes like activity, service, and broadcast receiver, you don't instantiate them. The OS will create those for you, and then it'll start calling methods into it, and that's where your application code kind of takes over. So you don't own those constructors, so it's not like you can add parameters to it for your dependencies. There's no way of passing those. There are some factories that were adding API 28 to work around that, but that's not a realistic solution, at least not for now. One of the libraries we recommended on that Android Dev Summit talk was Dagger. And Dagger is great. It's a dependency injection library that offers compile time validation of the dependency graph, and it has amazing runtime performance. But we did notice that it's hard to use, especially it's hard to configure. There's many ways to configure it, and we saw a handful of developers that had a hard time changing that configuration. Specifically, if you still knew how to use, if you were familiar with Dagger and you like switched to another app that had Dagger, you would still have a hard time using Dagger because the configuration might be different, or you wouldn't know exactly what are the subtle changes between the components and so forth. The thing is that we did a survey, and a lot of developers still ask us for a solution. So what kind of solution did we had in mind? Well, we thought of a few goals, and one of them was that we definitely wanted a little bit something more opinionated, and especially is so that we could make those choices for you, and because we make choices for you, things are easier. So something that's easy to set up. But more importantly, we want you to focus within the realm of dependency injection, to focus back on those dependencies, the definition of them, and just using them, and not have to worry about the wiring of these dependencies. So those were kind of like our goals. And this is where Hilt comes in. Hilt is actually a dependency injection library that was being used internally in Google for a bit, and we just rename it, change a few things, and open source it. But Hilt in essence, offers a standard way to do dependency injection in Android. And what that really means is all of those different ways to configure dependency injection change to just being the same. So if you ever work on an app that has Hilt and then go to another app, start some other work on some other app that has Hilt, things will be familiar. So you get that transfer of knowledge because things are standardized. Hilt is built on top of Dagger, so you get those same benefits that Dagger offer: compile time validation, amazing runtime performance. The solution that we had in mind is not only about library, we also wanted to do tooling support. So you can see this with Android Studio and the Dagger navigation. And because we know Android is an ecosystem, we also Hilt also offers extensions to work with other kind of hard APIs that for DI, mainly it has some AndroidX extensions for Work Manager view models, and we'll show some of that soon. All right, let's quickly go through how to set it up and how things work. So going back to our original example, we had a music player. This one's simple. It doesn't have anything on its constructor, not yet at least. To say we want to make the music player injectable into places, we annotate it with @inject. This is not a Dagger or Hilt annotation, it's a Java extension annotation. We have to create an application annotated with Hilt Android app. This kicks off all of the injection going on in your application, and then for activities or fragment, we start annotating them with Android entry point, and this makes Hilt inject these Android classes. And when Hilt injects them, it'll inject dependencies that you have declared with that inject. So we have a field here of that music player. And then once on create happens, you are able to use that player pretty easily. That's it. That's all you need to do to start getting injection going on in your application. It's pretty easy. To go into a more real world case, that music player originally depended on a database. So if we add a database as a constructor parameter, we now have to define a way to provide this database. We're using room, so we can't technically just annotate a constructor. Instead, we need another way to define dependencies. And for that, we have something we call modules. Modules are a Dagger concept, but because Hilt is built on top of Dagger, it comes along with that. And modules are basically a class that defines how dependencies can be provided. You create a class annotated with that module. That's the Dagger annotation. Installing tells, it's a Hilt annotation, and it tells Hilt where this module will be available. Here we use application component, so dependencies declaring this module will be available all around the application. The dependency definition themselves are methods, in this case with a provides, another Dagger annotation. The inputs of this method, the parameters, will be provided to you by Dagger, and the output is the return type, in this case a room database that we created using the database builder from room. That's it. With this, the music player now will be able to be created with our room database. We saw installing, and installing took a component. We saw application component, but what exactly are components? Well, I like to also think about them as DI containers, and I'll show you a bit why. Components are what Dagger defined as that glue that knows how to create your dependency. If we go back to our original example, that music player needed a database and some codes. That instantiation logic and the ordering of that's basically what a component is. To put it differently, component is made up of factories that know how to build stuff, but they also are in a way a container because they can hold into instances of the things that the factory create, and it's able to reuse them for other factories or for other parts of your code, and we'll see that in a bit. Hilt comes with a few predefined components, application component being one of them, and these match the Android framework classes. There's an activity component and a fragment component, and dependencies flow from one component to another. They're encapsulated similarly to how an activity is encapsulated in an application. and so forth. And what this really means is that data module that we had with our database, if we had installed that in an activity component, activities and fragment could get injected with that dependency with the database, but not the application component. Hilt offers components for services too, and we also have view components, one with fragments and without fragments. To try to put a different perspective into this, application component is managed by the app. So components define the when and where dependencies are going to be available. And they do that because they get managed, the components themselves get managed by the Android equivalent, app managing application component, activities managing each their activity component. And because things are encapsulated in a hierarchy, dependencies in the application component are accessible to the activity component because they have a greater lifetime. If we show a practical example, we inject the music database into the activities, into these two activities. The activity component basically, says, hey, application component, I know you know how to give me a database, give it to me, and it'll create one. But something interesting here is that we actually get two different music databases for this activity. And that's not quite right. You kind of want to share your database because you want to share that connection, you want to share some synchronization. So there are dependencies that you do want to share and have the same instance. And for that, what we use is something called scoping and scope annotation. So if we go back to our data module, we had a method that provided the database. If we now annotate it with a scope annotation, for this one we use singleton, then what Hilt and Decker does is they retain that music database across that component, and this is the container part. It can hold into that dependency so that if other factories or other places that need to be injected, you'll use the same one. So now we use the same music database for both of our activities. All of the Hilt components come with scopes. And again, components define the when and where, the life cycle of the dependencies. The scope then define the retention of those dependencies. They'll get retained for the lifetime of that component. Now, another concept that Hilt offers is something called entry points. Entry points are a way of assessing those components and their dependencies. And these are really useful for parts of your application that are not kind of supported by Hilt out of the box. One concrete example is a content provider, where if you try to Android entry point a content provider, it doesn't work. There's no content provider component that Hilt offers. They're a bit weird. They have a weird life cycle. They can be created before the app, so that's why they're not supported. But basically, in a content provider is where you want to use a database. So if the content provider had a way to reach out into the application component and get that database, how would it do it, right? And that's where entry points come in. They are a way of entering into your dependency graph. If we have a content provider, we create an entry point by defining an interface. We annotate it with the entry point, install it in the component where it's gonna be on and get retrieved. This interface has a getter method, and the return type is that dependency we want. Now on our actual query of our content provider, we use utility methods like entry point accessors to get that entry point out of the application context. And then from there on, we can start calling our getters and get those dependencies that we need. Pretty neat. So entry points are useful for all of those cases where Hilt doesn't offer out-of-the-box injection. We mentioned Hilt playing nicely with the ecosystem is important. So Hilt comes with Android X extensions for Work Manager and View Model. Work managers and view model workers and view models are interesting. You kind of don't own their construction injection. They have some weird instantiation, and Hilt tries to help you there with these extensions. One example of that is view model. You provider to create these. So you usually end up using a factory, but with Hilt, it's as simple as injecting annotating the constructor with viewModel inject. Then you pass your dependency as usual in the constructor parameter. Save state handle uses assisted. This just means that dependency don't have to be defined in your component. Hilt will know how to create it for you and give it to you, so it's assisted. And then on any under entry point that you have, you can use that view model that you had annotated previously, either by using the Kotlin extensions by view models, or simply using the view model provider. Cool. So those are kind of like the new Hilt annotations that we've learned so far. Now, the other side of Hilt, or a really important part of Hilt, is the testing side. Hilt offers quite a few APIs for better testing, which are pretty handy. If we wanted to write a test for a music player, we create a music player, but in this case, we don't want to create it with a real database. We want to create it with an in-memory database. And the reason we want to do that is because we want to isolate this test. We don't want to use a real database, that leaks between tests. We just want a database that we create here and get rid of pretty quickly. Creating this music player is pretty easy. We just create that database, but imagine if music player had 20 other dependencies, and those dependencies have more dependencies. So what ends up happening is that you will have to exercise your whole dependency graph to be able to create the instance of the thing you want to test. If you have fakes, you can use those, but then when you don't have fakes, you tend to mock, and that by itself has some other disadvantages. But with Hilt, we do injection in the test itself. So what happens is the things that you want to test get constructed the same way they would for your production code, which has the benefit of you don't have to manage creating all of those dependencies and transitive dependencies. So to do that, we start with Hilt Android test. We annotate our tests with that annotation. We create a rule, and the rule will be useful for injection later. Similarly to when we inject into our app, we create a field with an inject. On our setup, we use the rule to inject the test, and this is where we control the injection. And once injection happens, then you can start using that instance of the player and start writing tests and assertions. Now, one thing about this test is it created that music player with the same configuration we had on a real app. So it will use a real database, and that's not quite what we want. We wanted an in-memory database. What Hilt offers here to solve that is Hilt has a way to install modules, and then I can define a new module that creates the in-memory database. So I uninstall the data module that was the one using the production that created the room database, and then I define a new inner class for this test that creates the in-memory one. The cool thing here is that this module and this uninstalling only happens for this test. So the tests, multiple tests can have different configurations. So it's pretty flexible. There is some setup required. You do need a runner with some that creates an application that uses that's of type Hilt test application, and don't forget to use that same runner in your build.gradle. To recap, we saw 2 annotations here for testing, but there's actually a few more for other use cases, and I won't go into details on them. They're a bit special, but we got documentation on what kind of issues they solve. Something to keep in mind with testing is because you want to replace dependencies, that means you should pull those dependencies that you want to replace into their own modules. And since creating modules is kind of easy, I think this is something fairly trivial to do in terms of there's no cost of creating multiple modules, even if they just have one dependency that you know you're going to replace. Meanwhile, on a bigger code base, you should try to create smaller test apps. If you have a multi-Gradle project with many modules for a big app, convenient to create smaller test app to take coverage on certain areas, because then the scope of things you need to replace and redeclare as smaller. We know dependency injection can be core to your code base, and refactoring that can be tricky. So with that in mind, we do offer some migration guides, and mainly if you were already using Dagger or Dagger Android, Hilt can actually work side by side, either temporarily, hopefully temporarily until you fully migrate. Hilt offers some APIs that I won't mention here to help with this. We actually have a whole guide to give you some pointers on how to do this. Please check it out. But we do know changing, dependency injections library can be, can take a toll. All right, so that's gonna help on the basics, show you how to set it up, how to use it. But let's take a look at Hilt in itself and how it kind of works to give you more sense on some of the decisions that it makes for you. Hilt is really composed of two areas. One we like to call the aggregation part, and the other is the under entry points part. Let's take a look at the aggregation. Aggregation here means if you have multiple modules and entry points, they get aggregated. Let's take a small example here. Say we have an app. This is a Gradle module, and that's composed of a source set, and source set is classes. You have a class that's a module and has install in. In a bigger app, you have other Gradle modules, and all of those might have modules that also get installed in, and there's dependency between these Gradle modules. Well, Hilt is able to navigate through these transitive dependencies, and more importantly through the class path, and find those modules and install them on the right places. In other words, Hilt will aggregate those modules and entry point across your class path. And this has the benefit, it has a few benefits. One of them is that defining a module, if you're working on a big app and you're working on a small library part of that app, you can create a module, install it on the standard component, and it'll be easily accessible. You don't have to go into the root of your app navigating exactly where that module should go. It also has practical effects with variance and flavor, because they're aggregated across the class path, and variance and flavor affect your class path. You can have different configurations between your flavors and debug and prod variants. One concrete example of this is, say you have an OK HTTP client or a gRPC client. These have interceptors, usually for logging, authentication, and things like that. If you have a module that defines that client and you have no interceptors on your main, that means when you build your production app, you won't have any interceptors. But then, say on your debug variant, you want to have logging, then you can define a module only on the debug source set. And only when building the debug variant, that source set becomes part of the class path. Hilt discovers that module, aggregates it, and now ultimately you have logging only on your debug OK HTTP client. That's pretty neat. Going back into the aggregation, you might be wondering, if you're familiar with Dagger, you might be wondering what exactly is going on. And what's happening is, in those Gradle modules where you have your source set and your modules and entry points, you install into a component, and these class components that you use in installing is nothing more than a key to tell Hilt, hey, you should create a Dagger component based on this key. The way you define these component keys is through a define component, because a define component tells Hilt to generate a component. You can also annotate that key with a scope, and that scope will be added to that component. In essence, define component is what Hilt uses to create the other Android standard component, application component, activity component, and so forth. And what really happens is, Hilt looks at all those installs in, aggregates them, and generates a Dagger, a vanilla Dagger component definition. The modules will go into the app component module list, and entry points are just interfaces that get to be implemented by that Dagger component. Hilt offers this similarly with subcomponents. Define component can actually have parent attribute. So fragment component is based off activity component, and similarly service component is a subcomponent of application component. And that's how you form that hierarchy within your components. The standard components that Hilt offer are fundamental to Hilt. They really offer that simplicity of where the component is gonna be created in its lifetime. You have that knowledge transfer from one app that uses Hilt to another that uses Hilt. It really is the building block for other extensions. The Android X extensions, all they do is create more entry points and modules, and they get installed into their components. And they're key to kind of like the simplicity of Hilt, because they get standardized. Now you could define a component hierarchy yourself, but then you lose on the managing of those components. And this is the second part about Hilt. Hilt not only offers that aggregation mechanism and has the standard components defined, it also just offers a way to use those components via the Android entry points. And what Android entry point all it does is really generate a base class that knows how to member inject your concrete class. We changed your super class via some bytecode transform. That's pretty neat. But ultimately, all it does is member inject your concrete class. And the way it does that is because Android entry point also generates a vanilla entry point that has the member injection method that goes in the Dagger component, and that Dagger will generate an implementation for. After all, Android entry point is not that magical, and you could define your own component hierarchy, but then you will have to manage those components yourself. And similarly to Android entry point, you will have to do the member injection yourself. So with that, we learn a bit about Hilt, how to set it up, some internal semi-complicated stuff, I guess. But what's next? Well, Hilt is in alpha, and there's still more work to do, bugs to squash. There's also features we want to keep working on. We want to be able to allow you to use Hilt outside of Android Gradle modules. And we want to invest in other areas, not just on Hilt, but in Dagger being Hilt built on top of Dagger. We want to invest on Dagger, and we want to provide assisted injection out of the box. And expanding outside of Dagger and Hilt, but still within the realm of dependency injection, we do want to provide more Android X integration, possibly navigation, and we're thinking far ahead with things like Compose and things like that. That's about it. Please try it out, give us some feedback. Here are some links to more documentation. Dagger.dev Hilt goes in depth on a lot of the APIs. Dagger and Hilt are public, open source on GitHub. You can look at the source code, file issues there or questions. And we also have documentation on theandroid.com. These are more story-driven and use case documentation that are great for more newer beginners to the subject. That's about it. Thank you so much. Bye.